This use case is of a larger process plant where wood is digested to produce pulp of paper. The production depends on the operating conditions such as pressure, temperature, and of course on the quantities of water, raw material, chemicals, etc. injected. The flowsheet shows now the system complete from the pre-cooking and preheating part on the left here to the digester itself on the right side. The data is collected everywhere from sensors located at specific places. Important to know in this process that inside the digester itself, a production of the pulp along with other residues happens based on different conditions. The quality of the separation process and time, which normally takes between 3 to 6 hours, is usually quantified by a specific KPI known in the field as the blow kappa number. We now move to the project tab called Kappa Number Prediction, the aim of which is to predict these specific KPIs a few hours in advance. The dashboards list a selection of legacy data collected along 3 or 4 months. This includes the coal age factor, the digester level, blow temperature, blow kappa itself. This is the variable that we would like to predict in the future. ITC circulation flow, digester production, extraction of liquor flow, etc. Once the data has been collected over a sufficient period, machine learning models are created to predict the blow kappa based on variables selected by the algorithms. For example, let's just have a look at this pipeline. How does it look like? From the input to the output, creating the digital twin. Now let's move to the Insight Hub and see what all these models are doing. The main model for predicting the kappa is seen here, the performance of which is rather good. If we compare the real variables from the sensors to the predicted for the training period, which is only 80% of the signal, and then the predicted over the test, which is 30% of the remaining part of the signal. The same thing for 1 hour ahead blow kappa prediction, and we see that the model is performing rather well. Important for the users, of course, is how the blow kappa can be predicted for a couple of hours ahead of time, and this is how the model returns this prediction based on the number of days selected here for the prediction. We could be a little bit shorter, for example, last day, and the model understandably changes the behavior.